Hold on the camera right now.
Yeah. Hi there. I'm Oscar. This is Pablo, a co-founder of OnFabric. Catalina, one of the developers of the team, and Ismael, another developer. So I'll start by sharing my screen. How do we do that? Cool.
Yes, I can see your screens.
Yeah, I know.
Cursive attack.
Cool. So formally, welcome everybody to the second demo of the Dogecoin Ethereum bridge. Before we start, as we did in the previous presentation, I have to send a transaction. Just follow me a second. So I'll be sending coin to Doge. Right. So I have
Okay, one. Okay, yeah, I can see it.
I have to do this at the beginning of the presentation because this takes some time to confirm. You don't need to understand this now. I will get back on this later. I just wanted to show you that this is live, that I'm sending the transaction now, okay? Oh, again. Presentation. So we plan to do the presentation in 30 minutes, and you will have as much time as you want after that for questions and answers. Obviously, you can interrupt me if you need to. First, I think that we already introduced ourselves. Then we will review the objectives of the bounty. We'll give an overview of our GitHub repository and review the current progress of the project. We will explain the problems the previous solution had and how we fixed them. And that then is the core of the presentation, where we will explain how the bridge works and do a live demo of that. The demo will be mainly following the user guide that we already published.
Okay.
Then we'll see what is still to be done on the bridge. Summary, questions and answers, and that's it. Any question or comment so far?
Oh, let's do it.
Cool.
Sounds great.
Yeah.
Sounds good.
So, well, I think we already introduced ourselves, so I will skip this slide. Let's review the objectives of the project. The general idea is to create a fully decentralized bridge between Dogecoin and Ethereum, where users can send Dogecoin on the Doge blockchain to an ERC20 contract on the Ethereum blockchain, and they should be able to burn the tokens and get Dogecoin back. And all that should be able. Anyone should be able to do that in a way that is easy. Just for clarification, there was another project with the same name, Doge Ethereum. That project is not a bridge, and we are not related to that project. Just for clarification.
Yeah, so if you want to go in further clarification for some people watching, in the last bounty, there were some people with the difference. This is not an atomic swap between Ether and Dogecoin. It is actually a bridge that makes Doge become a Doge token. I'm just clarifying to if anyone is watching.
Yeah, that's correct. You don't need a third party to exchange the tokens. You send the tokens, it's like tokens, Doges disappear and tokens appear, then tokens disappear and Doges appear. Again, on github.com/Ethereum, you can find our pull request. There are 4 main impulses: the documentation, the smart contracts, the external agents to the bridge, and command line tools. In the previous demo, we showed the Dogecoin to Ethereum side that was working, but we mentioned that there were some issues that we needed to complete. And also, the Ethereum to Dogecoin side was not even started. Today, we are presenting a completed solution of the Dogecoin to Ethereum side. And the Ethereum to Dogecoin side was implemented, but there are some things that are missing that we will explain at the end, but the solution is working. I think there was a lot of hype on social media about the bridge arriving mainnet these days, and I want to clarify that that's not the case. We made a lot of progress, and we are close to that, to a release, but we are not there. So I think that Ross mentioned that a couple of times on social media. I don't know if Ross you want to say something about that.
Okay.
Ross?
Yeah, can you hear me? Yeah.
Yes.
Yeah, so we've had a few people get a little bit overexcited about this. So I've tried to cool them off a little bit and tried to say, yeah, this is still a work in progress, and we're going to look up where the actual plans are from here.
Cool. All right. Let's move on. So let's review the solution that we presented in the previous demo. So we had a system that was very similar to BTC Relay, but adapted for Dogecoin. And there was a Doge token contract, an ERC20 contract where the tokens were minted. One of the problems that the bridge had when the implementation was started was that every time a Dogecoin block is sent to the Doge Relay, well, it's renamed now, but back then was Doge Relay, it had to be verified. And to verify its proof of work, since Dogecoin uses a script hashing algorithm, it requires 300 million units of gas to execute the validation on chain. And that's impossible to execute on chain. So we implemented for the previous demo the script hash interactive verification, and that solved that problem. Then we thought that all the gas consumption problems of the bridge were solved, and that's where we were at the previous demo. The problem we found with this solution is that every single Dogecoin block header has to be sent to the contract. And since Doge produces 1 block per minute, we estimated the gas cost per day for sending all that headers at $6,000 US per day. And that's a fixed cost. So no matter transactions are being sent from Dogecoin to Ethereum and back, $6,000 US per day should be spent. Well, a little less today because the Ether price went down, but that's the current estimate. And that is too high for a bridge that we still don't know how much users it will have. So we created a new solution based on a concept that we named Superblocks. Actually, we wrote a paper about this Superblock concept because I think it's not only useful for bridging Dogecoin to Ethereum, but it may be useful for bridging other blockchains to Ethereum. So here's the idea. We group blocks in what we call a superblock. So all the blocks that are created during 1 hour are put in a superblock. Then you have a super blockchain that is similar to a blockchain, but just with the super blocks. And so just a summary of the super block is sent to the contract. technically, it's the Merkle root of the Dogecoin blocks. So let's see how it works. So anybody can send a super block or propose a super block to the contract, and the contract will build its copy of the super blockchain. So if I say that anyone can submit a super block, that also means that anyone can submit an invalid super block. And the contract does not have any immediate way to verify that. That's why there is an actor in the system that is the superblock challenger or verifier that will be monitor all the super blocks that are being proposed. And if she detects an invalid one, it will send a challenge. And a challenge response battle will be started between the superblock proposer and the superblock verifier. If the superblock was in fact invalid, the superblock proposer will be punished, and the superblock challenger will be rewarded. There could be many things that can be wrong in a superblock. For instance, one of the blocks that belong to a superblock, its timestamp could be out of the established range. So for instance, for the superblock that goes from 4 p.m. to 5 p.m., you cannot put a block at 5:50 p.m. Another thing that can be wrong in a superblock is one of the blocks proof of work. And we are still using Truebit protocol to validate that. Any questions so far?
Yes. So about 1 hour
Is there
super
a-
block. So about the 1 hour super block. Does it mean that 1 hour is like an arbitrary number, right? Does it? So I have two questions. Does it mean that in the situation that I need the super block, do I need to wait for 1 hour until someone publishes like my block? And the second question is, if the bridge is not being used, does that it still mean that I need to have 24 transactions per day, or that means that someone can send like a super block that includes all days transactions?
Okay, so first question. First, super blocks are sent with certain delay. And yes, if you send a transaction moving from Dogecoin to Ethereum, you have to wait some time until the super block is published. You don't get the Doge tokens right away. I don't know if that was the first question.
Yes. So you need to wait maybe like probably more than 1 hour, right? 1 to 2 hours between.
Well, actually, you need to wait 4 hours because super blocks are publishing with 3-hour delay. You can go on that further on, but yeah, there is super blocks are 1 hour long and are publishing with 3 hours delay. The second question was, well, we still need 24 transactions per day. That's correct. There is so yes, the 1 hour sizes are required. There is a trade-off between the size of the super block and then the amount of gas that super blocks emitters have to spend per day, and how much time the user has to wait. So the bigger the super blocks, less gas to be spent by super blocks emitters, but more time for users to wait, and the other way around. So we thought that 1 hour was a good trade-off, but eventually, well, before we publish that into production, we can change that concept. The other question was if someone could publish a super block that compensates other super blocks. We don't. That is not implemented. The problem is that if a huge super block is publishing, the challenge response value for that super block will take a very long time. So we thought that it's best to keep publishing Superblocks at a fixed rate.
Okay, thank you. Piper, I think you're going to ask a question.
You asked the question I was about to ask.
Okay.
Shall I continue, or are there more questions?
Not for me.
Okay, you'll have time later on. Don't worry. So to send a transaction from Dogecoin to Ethereum, it works pretty similar as it used to work. A user has to send a locked transaction to the Dogecoin blockchain, and then inform the smart contract that she sent that transaction. And she has to prove to the smart contract that her Doge transaction was included in a Dogecoin block. And the new thing is she also has to prove that the transaction, sorry, that block is included in a super block. All that is done by sending SPV proofs of inclusion. So that's all the user has to do to get the Doge tokens minted. More questions? Okay, I'll move on. So let's review now the solution for the other side of the bridge.
Actually, sorry, before you move on, the size of that transaction with the SPV proof, have you guys measured it? Is it a relatively fixed size, and do you have an idea of what that transaction costs? In terms of gas, not necessarily the fluctuating dollars cost.
Yes, I don't have that in mind because it will depend on how many. Actually, you have to send the Dogecoin transaction and 2 SPV proofs. The size, the SPV proofs that proves the transaction inclusion in the Dogecoin block header depends on how many transactions are in that Dogecoin block. And the other SPV proof, it will be a tree with 60 leaves, so it won't be huge, but we haven't estimated that yet. The good thing is that cost is paid by the user who is trying to move coins. So you are not imposing like a fixed cost on someone that is not. So the user is willing to convert the coin. So I think it's regardless of the cost, it's a variable cost. You see what I mean?
Yes, I just was curious what the expected baseline was, but it's not a big deal. We can move on.
Yeah, I think we can do an estimate and later after the presentation and send you the information afterward. Okay. So back to the Ethereum to Dogecoin side of the bridge. So I was saying that Ethereum and Dogecoin are two blockchains that are very different. So the solution that is implemented for the Dogecoin to Ethereum side of the bridge is completely different than the solution that we implemented for the Ethereum to Dogecoin side of the bridge. When we began the project, our idea was that we will eventually add an opcode to the Dogecoin blockchain. We will eventually modify the Dogecoin source code, and we finally realized that solution was not that easy to implement. The main problem is that Ethereum is probably going to move to some form of proof of stake in the near future, or we don't know when, and that will break that solution. That's why we decided to implement another approach, which is based on collateralization. And well, I will explain how this approach works. A new actor is added to the system. They are the operators. The operators are the custodians of the Doges that are locked. Yeah, just a reference. Lock is the action of moving coins from Dogecoin to Ethereum, and unlock Ethereum to Dogecoin. So operators are responsible for storing and custodying Doges while they are locked, and also returning them to users when an unlock is requested. So when a user wants to send Dogecoin to Ethereum, actually the lock transaction that they are sending is a Dogecoin lock transaction to an operator, one of the registered operators. The thing that makes this system decentralized is that anyone can become an operator. And all it's needed is to add some Ether deposit on the smart contract. The Ether deposit acts as a guarantee or as a collateral, making sure that the operator won't run away with the Dogecoins she has in custody. So if the operator misbehaves in any way, stealing the Doges or not returning Doges to user when it should, the operator will be penalized by confiscating her Ether deposit. So to make sure that the Ether deposit covers the Dogecoins the operator have in custody, the contract needs to know the current Dogecoin Ether price. So there is an oracle that keeps the contract updated with the current Dogecoin Ether price. So eventually, when a user wants to do an unlock, she sends a transaction to the contract. The operator notices that and sends a Dogecoin transaction back to the user. Questions?
I have a question. So, what is happening with the Doge of the operator itself? And meanwhile, so when I want to become an operator, like how that happens? Do I need to have an account, a Doge account that I can prove that I'm holding the Doge? That wasn't very clear for me.
Okay, I will explain that. So yes, you need a Dogecoin address and an Ethereum address. So what you have to do is to establish your Dogecoin address, and with the Ethereum address you have, you send a transaction to the contract, registering yourself as an operator. And then you have to add some Ether to the contract. So you don't have to have any Dogecoins when you start. You just need Ether, and you will be getting Dogecoins. So all you have to do is to install the software that we created, and that will monitor the Ethereum blockchain. And as unlocks are requested, it creates a Dogecoin transaction from your wallet. I don't know if that explains wrong that your question was.
And operators are free to do whatever they wish with the Doge that they hold because it is collateralized. Is that the idea?
Well, no, I think this was it's a question that we thought about that a lot. Actually, we sent that same question to you, to the judges, like a couple of months ago when we had to make this decision. So there were two options. One is, well, since the operator have deposited the Ether, so let them move the Dogecoins, spend them, do whatever they want, as long as they return the Dogecoin to users when requested. So that was one approach. The other approach, which is the one that we implemented, is they cannot move the Dogecoins. If they move the Dogecoins, someone can denounce that to the contract and then will be penalized. And the reason for not letting them use the Dogecoins, if we did that, at the same time, it will be Dogecoins and Doge tokens in circulation, and that kind of will increase the Dogecoin monetary base. So that's why we decided to go with the option of not letting operators move the Dogecoin while live.
All right, so to repeat that back to make sure I understand correctly, operators are not fully bound, so they are capable of moving Doge that they are in custody of. But if they do, there is a mechanism in place for somebody to report this, at which point some sort of slashing condition comes into play.
Exactly, yes.
Cool, that sounds good.
I have a question actually as well. So you're talking about consensus changes, and particularly the Ethereum proof of stake change that's planned. Is there a mechanism for handling any further changes either on Ethereum or Dogecoin sides? So if we had a consensus change on Dogecoin, can we modify the Superblock verification process in some way?
Okay. I have an answer. We don't have the full solution, but let me tell you what we know.
Cool.
So
We can come back to it later if it's a difficult question.
yeah, so there are two things that will happen. Actually, four things, but let's start with one. Let's start with the Dogecoin 4. So there could be two types of Dogecoin forks. If the forks keeps Dogecoin proof of work algorithm, the bridge will just keep the bridge will just follow the longest Dogecoin chain. That's the decision we made, and that's what the bridge will do. If Dogecoin changes its proof of work algorithm, well, that's kind of a big deal, and we are not ready yet to cope with that. That was the question, or can I answer any other thing?
Yeah, I think that's enough for now.
I want to expand on the question on what happened with the Dodge on the side. So when you answered Piper, basically the answer was that if the Dodge moves, then there's a slashing condition. And my question is the slashing condition if any Dodge moves at all, or is there some sort of a thing where you're constantly comparing how many Dodge they have on their account versus how many Dodge they have like bonded on the Ethereum token side? So is it something where if suddenly there are less Dodges on my Dodge account, I will start burning Dodges on the other side until it equalizes? Or is it the case that once I've moved the token without like the proper authorization, then I lose all the Ether bonded and like chaos happens?
Oh, so
But that's good.
yeah, so Dogecoin has a different account system than Ethereum. Dogecoin is Bitcoin based, so there are no, let's say, there are no accounts. So what we have instead are UTXO, unspent transaction output. So every single transaction creates one or more outputs, and the operator, what it has is a set of outputs that she can spend. So if she moves any of those outputs without being requested, she will be penalized. I don't know if that was the question.
Okay, yes, that answers my question. Let's move on.
Okay. Maybe Pablo wants to say something.
I want to say that there is a transaction in the Hangout that shows the amount of gas needed because it's a transaction. It's exactly what you want to know. There is a transaction in the testnet, so you can see how normal transactions to claim the Doge tokens looks like.
Yeah, this answers Piper's question before.
I'm sorry, I had a lot of trouble hearing that. Was that I the only one, or was the sound very grumble when like?
Pablo,
So if you can approach the microphone, Pablo.
yeah, Pablo was saying about the question that Piper asked early on about the Dogecoin to Ethereum side of the bridge. Piper asked how much a transaction to claim those tokens will cost. And I answered that I don't know. And Pablo is saying that the answer is on this Google Hangouts chat room. That he posted a transaction on Etherscan where you can check that.
Okay, thank you.
All right. Shall we move on?
Yes.
Okay. So let's review the actors that are part of this system. One actor, the main actor is the user. The user can convert Dogecoin to Doge tokens and convert Doge tokens back to Doges. The user can also transfer the tokens to her minis or MetaMask wallet and use those tokens as any other ERC20 token out. The Superblocks leader are responsible for keeping the contract up to date with the news on the Doge blockchain. Superblocks and leaders send propose Superblocks to the contract. Superblock verifiers, they make sure that no invalid Superblock is accepted by the contract. Operators, they store the Dogecoins that are locked while they are locked and return them to users when requested. And the price oracle keeps the contract updated on the Dogecoin to price. So it's time for the demo right now. I will switch to the command line. This is probably the part of the presentation that is more difficult to understand because I will be typing a lot of commands and I think I may lost some of you, but I will try to explain everything that I'm doing and try to keep with me, right? Okay, so do you remember at the beginning of the presentation, I sent a lock transaction sending coins from Dogecoin to Ethereum? So here is the hash that was created. And I'll go and check on a Dogecoin block explorer. Oh, again, this. On a Dogecoin block explorer, whether that transaction was broadcasted on the Dogecoin network. Okay. So I see that here that 9.2 Doges were sent. Now, what I will do is I will go back to the command line. Yeah, let me explain something before. On this computer, I am running a Dogecoin node, an Ethereum node, and I also installed the Doge Ethereum command line tools, and the lock command is one of them. So there's another command which prints the balances. So let me use that one. Okay, I will put the address that was assigned to me. Okay, so now you see that I have 7.2 Doges. You might be wondering why, if I send 9.2, I got only 7.2 Doges. And let's go to Etherscan and see if we can find the answer for that. So here is the Doge token contract on Etherscan Rinkeby. So I will refresh. And I see that, in fact, yes, I got 7.2 Doge tokens. The thing is that since operators and Superblocks emitters are spending money on the bridge, they need to be rewarded somehow. And here, one token was assigned to the operator, and one token was assigned to the Superblocks emitter. That's why I got a little less than what I sent. So here, the next thing I have to do is to import my private key to my Dogecoin private key to my Ethereum node. There's another tool for that. I'm getting there. Yeah, import Doge key. I will use that one. Okay. So now, well, you saw that I have 0 Ether on that account, and I need some Ether on that account to be able to send transaction. So I will send some Ether just to be able to pay for gas from that account. This is not what I intended. 1 second. I will put the new account as a receiver. Now the transaction is being sent over the Ethereum Ringkebby network. Oh, that was weak. It was balanced fast. I think I sent a little less at what I meant. So I will add a couple of zeros here. Okay, this time the transfer of Ether is taking a bit longer. Come on, Ringkebby.
While we wait, I assume that those fee values, the 1 Ether, are sort of arbitrary numbers at this point. Is that accurate?
Well, they are a percentage of the amount being sent, but there is a meaning of 1 token when the transaction is sent. So if you are sending like 500 Doges, the minimum won't affect you. But since I'm testing with very small amounts, the minimum fee seems a lot.
Got it. So if somebody tried to send 1 or 2 over, they would get nothing.
You won't be able to send 2.
Got it. Cool.
The minimum is 3. So let's print the balances again.
But to expand on what Piper's saying, I suppose that's an easily configurable thing, right? And I suppose, is that something that each one of the node operators can set their own prices for it, or does everyone need to work with the same prices?
Currently, the price is hard-coded, but that's kind of a good idea. I didn't think about that before. We might evaluate that, like create like a market for operators where users can choose cheaper operators. Yeah, that would make sense.
Yeah.
Sounds like a nice feature, but we don't need to get too sidetracked on that today, I guess. But yeah, I like that idea a lot.
I just need to understand if that's something that's possible, right? I mean, as long as that's possible, then that's okay. I just wanted to, if you like you need to do it hard coded, then that would be a problem.
Okay, so now what I will try to do is I will try to send some of my tokens to my MetaMask wallet. I'll go to my MetaMask wallet. Here you can see that I already have some Doge tokens, but I will try to send here a couple more. So I will use the transfer tokens utility. Transfer tokens. Right procedure. I have to change the standard. Okay, yeah, I will send a couple of tokens. Transferring 2 million tokens. Let's use the MetaMask. Cool. So I have 9, I now have 11. Here on MetaMask, I can transfer this. I can use, as I said, as any other ERC20. So, the last step of the demo will be to converting Doge tokens back to Dogecoin.
You're cutting out a little. Can you make sure you speak into the microphone, please?
Say that again, please.
You're cutting out a little. Can you make sure you're speaking into the microphone?
Yeah, okay. So I will try to speak louder and closer to the microphone.
That
So
is
I was
much better.
saying,
Thank you.
so I was saying that I will go to the last part of the demo where I'm going to send tokens back to Dogecoin. So to do that, I'm going to use the unlock command that is also part of the Doge Ethereum tools here. I will say that I'm sending from my address, and I will be sending to a Dogecoin account, a Dogecoin address that I control. I will send, let's say, 5 tokens. I'm unlocking 5 Doge tokens. There's a transaction being sent to the Ringkeeper network, and I'm waiting for it to be included in the block. It was included. So now here is my Dogecoin wallet. Now we should wait for the operator to notice that the unlock was requested and send 5 Doges back to me. This could take a little, so maybe if there are questions.
Yeah, I have a question. So is this the point where you would be waiting for 1 hour for the Superblock? In which point of the demo we would have to wait 1 hour for the like 4 hours for Superblock?
Yeah, the moment where you have to wait more when you send Dogecoin to Ethereum. Since we deploy the contracts on Ringkeeper and to allow users to test the system faster, we set the constant to 10 minutes instead of 1 hour on total transaction. We send for the current deploy we created we established the super block size to be 10 minutes. So so you can test faster. But you saw that I had to send the log transaction at the beginning of the presentation, and not until I got into the part where I did the demo. Well, I had some time for that transaction to be included in the blog and the super blog. Does that answer the question?
Yes, and to try to understand that better, is there a difference between like the time in which the contract is first able to see that you have sent a coin, and then when it's certain that you have like that there's no dispute that you have that coin, right? So is there, let's say that is there like do you see it in like first 10 minutes, but then you have it like unconfirmed for 4 hours? Do you see it for 1 hour, like after 1 hour you see it, but it's unconfirmed for sort of in an unconfirmed status for 4 hours? Or is it something like only after a few hours the contract will even be aware that there's something going on?
You have to wait 4 hours. There is no kind of unconfirmed concept that you have on blockchain transactions.
Okay.
More questions?
Well, there could be unconfirmed status, which would be sort of like the block is in, but there's still time for someone to make a dispute about the super block, right? So there is in theory a sort of uncertain status at some point.
Well, I mean, you can see that the transaction was sent on the Dogecoin blockchain, and you can follow the confirmation on the Dogecoin blockchain. But I mean, we want to reduce that being spent, so the transaction is just informed to the contract when it is ready to mint the tokens. Because we could inform it beforehand, but I think it won't help a lot.
Alex, is your question more of like a UX oriented question, as in would it be possible to display these unconfirmed, not yet included in Superblock transactions on like a user facing thing? Is that
that's where I was getting on, but I was trying to understand if I was trying to understand if there was something that we could use to display user. I'm thinking in UX terms, but I was trying to understand if there's like what's happening behind the scenes.
Yeah. Yes. On the user application, the visual application that we still need to build, the user will get feedback during these 4 hours. It's not that they want. It will be waiting for 4 hours. The user will be notified of what's going on. All right, more questions.
Okay, thank you.
Okay, so you see that I receive a 1.5 Doge payment when I send 5 Doge tokens. The reason again is fees. The operator gets 1 Doge token, and also the Dogecoin miner fee has to be paid by the user. So depending on how big the transaction is, that's the cost of the transaction will vary, and that's why I got less than what I sent. Okay, shall I move on with the rest of the presentation, or are more questions so far?
I would vote for us to move on. That sounds good.
Okay, cool. So let's go back to Prezi. Okay, what we still have to do? As I was saying, and also as you saw, I had to use the command line to move coins from Doge to Ether and back. Many users are not comfortable using the command line, so a visual application is needed so anyone that can use a computer can move coins. On the Ethereum to Dogecoin side, there are 2 things that we still need to do. One is penalizing operator when they misbehave. So I said that operator has to deposit some Ether. That is implemented. The part that is still to be implemented, that if an operator steals the Doges or a user requests an unlock and the operator does not send the Dogecoins back to the user, in that case, the Ether should be the Ether deposit of operator should be confiscated, and that is still to be implemented. The other thing that is missing on the Ethereum to Dogecoin side is I said that there's an oracle that informs the price. Currently, we are using a centralized oracle that is controlled by me, basically. And we should move to some way of decentralized oracle. And the other thing that needs to be done is a security audit, because if this is going to put into production, we don't want people to lose money because we had a bug. All right. There are a couple of things that are completely out of scope for this presentation and for the project in general, but we wanted to mention them anyway. During the research we did to create the Superblock concept, we investigated a lot challenge response mechanism, and we found some similarities with the state channel concept. And we would like to see if the state channel concept could help somehow um, improve challenge response mechanisms and protocol. So that's something that we might investigate in the future, or we would like to hear if there is already research on that area. The other thing is, well, during the last week there was like a twist storm about Doge Ethereum on social media, and many people were asking what Doge token will be useful for. We even got asked if users could buy CryptoKitties with Doge tokens. So we would like to invite the community to start building applications that use Doge tokens. So when we are ready to move the bridge to productions, users have already some useful use cases.
Crypto doggies.
Yeah. So summary. The bridge is running on Rinkebi. Please go ahead, play with it. If you find any bug or any problem, please create an issue on our GitHub. The Dogecoin to Ether side was completely refactored using the Superblock implementation, and the Ethereum to Dogecoin side of the bridge was implemented using a collateralized approach, but there are some things that still have to be completed. So I think that's all from our side. Now it's time for questions and answers. So we are on here.
I'm gonna jump in here because I have a hard stop coming up, and this is not exactly a question. I'm just giving my quick feedback before I drop off. In general, this looks really promising. I like the work that you guys have done, and that I believe that I have my head loosely wrapped around all of the pieces that you just demonstrated. I have some feedback that I'll probably send just via email because there's no need to go over it here. But I think that a lot of what comes next, for me at least, hinges a lot on now this like polish piece that comes next, which is the like user-friendly facing version of this. And I have some suggestions I'm going to send over an email, but in general, I like where this is going quite a bit.
Thanks,
Cool. No problem. Thank you for putting the time into this. I'm going to drop off right now, but I will send a follow-up email with some of my thoughts.
Cool. Bye.
Okay.
Yeah, so this looks good to me. I've actually got some sort of almost inverse questions, which is I'm thinking about what do you guys need from the Dogecoin developers next? So I'm basically thinking through, it looks like I should start spinning up nodes that we then can start stress testing this with and actually start beating on it with sticks and trying to see if we can find any problems. A sort of an early stage security audit. Does that make sense?
Yeah, reviewing the source code will be a good thing to do, and testing that. I think that it was very useful, the articles that Euros published explaining to users that have no idea about how the bridge works, because the documentation was written by me and I know exactly how it works. So maybe I'm not in the head of someone that does not know. So it's good to have documentation from people that are not working day to day on the project. That's all I can think. I don't know, Pablo, if you think there is anything else that we don't continue to help us.
I think testing and reviewing the code is a good start. And we will continue reviewing and fixing all the reporting issues. So that's good.
Cool, cool. I will try to get another blog post out about this later this week. So give everyone a bit of a summary of what's gone on. I'm hoping there'll be a permanent copy of this video somewhere. I don't know if that's something we've got set up. But if you've got a link you can send me with that people can replay this later, that'd be amazing.
I believe it's on YouTube, and I think it's the thing that it's live now. So I think if you see the link that I posted on the chat, it's probably where that presentation will be.
Cool. I will double check that afterwards, but it sounds great. Okay, thanks a lot. Yeah, so I'll try to get a blog post out over the next couple of days, and I will also try to look over the code over the next couple of weeks and start really thinking about the complex corner cases and any questions and stuff.
Cool.
Okay, Oscar, could you go back to the presentation where you're saying like what's left to do? I'm curious to take a look at that and ask questions about that.
Yeah. Okay. 1 second that I have to share my screen again.
Sure, no problem. I wonder. I remember one of them was an oracle, and I wonder if it would be sufficient to have an oracle-based decentralized exchange on the. It's the what's next. That's it. So I wonder if like once so about applications, right? You mentioned that you don't have any application for the Doge token, and I agree that's out of scope. And maybe we could reserve part of the bounty for people to create applications out of it. But in the end, that's an Ethereum token, and any application that works with Ethereum tokens will work with Dogecoin. That's sort of the magic of Ethereum. But that also means that any of the current, there are multiple decentralized exchanges, and they would be able to provide you with the price of the Ethereum Dogecoin token, right? So that could be a very useful oracle. It might have some sort of there might be some problem there because sort of like the price of the token will interfere on how the token is traded. So there might be some manipulation, especially if someone can pull the price of the token away from the price of Doge. So that would be interesting to see. And penalize operators on misbehavior. I suppose that's. What do you mean by you still need to build that part where you're going to penalize operators, right? You can detect when an operator will misbehave. It's just that you haven't written anything that penalizes them. Is that what you mean?
Yeah, in order to, let me answer the first question first about the decentralized exchange. Yes, I think that probably using a decentralized exchange to know as an oracle will be probably the most reasonable thing to do. But since we haven't thought about that a lot, I haven't mentioned that solution, but that's probably the first solution that we will investigate. About penalizing the operators, so the functionality is there, so operators can now go and deposit Ether on the contract as collateral. The contract code is implemented. The operator tool for depositing the collateral is implemented. But what is not implemented is what happens when an operator steals the money. So what needs to be implemented is first a logic in the contract where anybody can report misbehavior on the operator side, and also the code to let anyone do that. I mean, the code for the contract and the external agent that keeps monitoring the Dogecoin blockchain and checks if any operator misbehave and report that to the contract. I don't know if that answers the question. Hello?
Hello?
Alex?
Yes, yes. Can you hear me? Yeah, that does answer the question.
Okay. So we're ready for more questions or comments or whatever.
Now, I'm also going to go and see if I can look at some of the discussions we need to have with exchanges and similar about things like the oracles. If we can get a Doge Ethereum market set up on a couple of exchanges, actually that'd be perfect for the oracles, rather than having to go through a third currency. And there's all sorts of things I want to start discussions on with that. But I think there's a lot to get on with there, and it's good. And I think it's excellent progress.
Yes, so my final comments on it, I'm very excited about it. It seems that, so I have the impression that, I think that if you wanted to deploy everything right now on mainnet, I have the impression that it would probably work except for the part of penalized operators. So that's the only part where I would say that the bridge isn't really like sort of complete until you put the penalized operators part, but that seems easy to be able to, to go back. It seems easy because all you need to do is you want to distribute Ether to people and you want to bring down the amount of tokens on the supply. So basically the contract will be buying back tokens, right? And I feel that I feel like the other steps were creating apps, creating a visual interface. That does seem like something that I would leave for like the last bounty, and even like I would wonder how we can include security like the security audit on which step that would be. But I want to say that I'm very impressed with the work, and I think it's very important. If we take a look at things like Shapeshift just started asking for KYC information. That means that what was once a very flexible ecosystem where you could have one token in one blockchain and trade it for the other, it's slowly becoming a more rigid one where it's not so easy for one crypto to become another. So that's why it's very important for us to have decentralized technologies that allow crypto to crypto exchanges without needing a central operator. And I think that's very useful for the ecosystem as a whole. And that's I'm very happy to see it. And I'm very happy to see that you've been writing papers and working, which is basically like research, and I'm very happy to see it. So I think my next step would be I want to see like feedback from the other judges. I want to see like what other people have to say. But my opinion is that it's just a question of that's of how much work there still needs to be done, and how much of that work is actually the sort of thing that will be very complicated, or what is sort of thing that will be mostly just wrench dressing to make it easier for users. So, but I'm very excited about it, and congratulations on the work.
Thanks, Alex. Well, I don't know if Pablo, Catalina, Ismael want to say anything else.
So maybe in connection with Alex, as you saying, Alex, I think that most of the research is done. That is the worst part because it's what you cannot measure. Now there are some work to do and some bugs that to fix, but we see that most of the most important work is done. We want to make it more fancy or simple to make it work for operators and as well as the users. So that's, I think, the target of the next part.
Has anyone got any questions about the Superblocks protocol? No technical worries about that.
Sorry, Catalina, could you speak a little bit closer to the microphone?
Yeah, sure. Has anyone got any questions about the technical aspects of the Superblocks protocol, or is that clear?
No, all my questions were answered during the demo. I want to be able to. I'm going to see if I can try to run it myself, but
Yeah.
not for me.
Oh, yes.
Ross?
I think it's all clear. I'm going to look through the code. I may come back with some questions based off that, but it looks all clear. I posted into chat, but I'm going to have to run, unfortunately. But thanks, everyone. It's looked really good. Thanks. Bye.
You're very welcome. Thanks to you for listening and for your positive feedback and for supporting this project.
Okay, Ross, thank you. Alex, I think we can wrap up here.
Yeah, we can. Thanks for doing this demo, Oscar.
No, you're.
Thanks, Catalina, and everyone on Coin Fabric.
Yeah, thank you, and looking forward for moving on. Okay, bye-bye.
Bye-bye.